Humans perceive colors through a complex process that begins when light enters the eye, passing through the cornea and lens before reaching the retina, where specialized cells known as cone photoreceptors convert the light into neural signals that the brain interprets as different colors based on their varying wavelengths. Once the cone cells, specifically the short, medium, and long wavelength cones, detect specific wavelengths corresponding to blue, green, and red light, they send distinct signals to the brain's visual cortex, which integrates these signals to allow us to perceive a wide array of colors through a process known as color mixing. This additive color mixing occurs when different wavelengths of light combine. For instance, when red and green light overlap, they create yellow, showcasing how our perception of color can result from the combination of different light stimuli rather than solely from individual colors. Moreover, it is essential to recognize that not all humans perceive colors in the same way. While most individuals can see a wide range of colors due to healthy cone function, some may experience color vision deficiencies such as red-green color blindness, which results from anomalies in the cone cells that limit their ability to distinguish certain hues. Understanding how we perceive colors not only sheds light on the mechanics of human vision, but also highlights the fascinating differences in color interpretation across individuals and species. For instance, many animals, like certain birds and insects, have additional types of photoreceptors that allow them to see ultraviolet light, thereby expanding their color perception far beyond what humans are capable of. This variability in color vision is a product of evolution, as different species have adapted their visual systems to meet specific environmental needs and social interactions. For instance, animals that rely on camouflage or those that use vibrant colors for mating rituals have developed unique adaptations that optimize their ability to detect and differentiate colors in their habitats. A black hole is a region in space where the gravitational pull is so strong that nothing, not even light, can escape from it, formed when massive stars collapse under their own gravity at the end of their life cycle, leading to an incredibly dense point known as singularity, surrounded by an event horizon which marks the point of no return. As a massive star exhausts its nuclear fuel, it undergoes a supernova explosion, shedding its outer layers and leaving behind a dense core that can become a black hole if its mass exceeds a certain threshold, collapsing into a point where the gravitational force is infinitely strong. The immense gravity of a black hole warps the fabric of space-time, creating a gravitational well that influences the motion of nearby objects and even lights, causing them to spiral inward, while anything crossing the event horizon is inexorably drawn toward the singularity, where all known laws of physics cease to function. Matter that falls into a black hole forms an accretion disk, where it heats up and emits X-rays, illuminating the area around the black hole, while theoretical physicist Stephen Hawking proposed that black holes could emit radiation due to quantum effects near the event horizon, leading to the possibility of them gradually evaporating over astronomical timescales. Supermassive black holes, which can contain millions to billions of solar masses, are commonly found at the centers of galaxies, influencing their formation and evolution, with research indicating a relationship between the mass of these black holes and the galaxies that host them, suggesting they co-evolve over time. The merger of black holes generates gravitational waves, ripples in space-time that can be detected by observatories like LIGO, providing crucial evidence of their existence and allowing astronomers to gain insights into the nature of these enigmatic objects and the dynamics of the universe. Black holes can be classified into various categories, including stellar black holes formed from collapsing massive stars, supermassive black holes residing at galactic centers, intermediate black holes hypothesized to exist in the mass range between stellar and supermassive, as well as primordial black holes believed to have formed shortly after the Big Bang, each type contributing uniquely to our understanding of cosmic phenomena. An engine is a machine designed to convert fuel into mechanical energy, which it achieves through a series of processes that occur within its internal components, leading to the movement of vehicles or machinery. The process begins with fuel entering the engine cylinders where it mixes with air, and this mixture is then compressed by pistons moving within the cylinders, preparing it for ignition. Once the air-fuel mixture is compressed, a spark from the spark plug ignites it, causing a rapid expansion of gases that forces the piston down, generating power for the engine. After the power stroke, the burnt gases need to be expelled from the engine, which occurs when the exhaust valves open, allowing the used gases to flow out through the exhaust system. Throughout this entire process, the engine also relies on a cooling system to manage temperatures and a lubrication system to ensure that moving parts operate smoothly without excessive wear. Once these systems work in harmony, the engine can efficiently convert fuel into motion, powering the vehicle while providing real-time feedback through the dashboard indicators that keep the driver informed. As technology advances, alternative power sources like electric motors are being developed alongside traditional engines, leading to innovations that focus on efficiency and environmental sustainability in the automotive industry. This evolution in engine development occurs in cutting-edge manufacturing plants where skilled workers and robotics collaborate to produce both traditional and hybrid engines, ensuring that vehicles meet the demands of contemporary society. As awareness of environmental issues grows, there is an increasing push for cleaner transportation options, leading to a significant shift in the automotive landscape from traditional combustion engines to more sustainable electric vehicles. This transition not only aims to improve fuel efficiency, but also enhances the quality of life by reducing emissions, enabling families to enjoy road trips in a more environmentally friendly manner. Wi-Fi is a technology that allows electronic devices to connect to a wireless local area network, enabling them to access the internet and communicate with one another without physical wires, using radio waves to transmit data over short distances. The way Wi-Fi works involves a router that connects to the internet via a modem, translating the internet data into radio signals that can be transmitted to nearby devices, which in turn receive these signals through their built-in wireless adapters. To enhance connection speed and range, Wi-Fi operates on different frequency bands, primarily 2.4 GHz, which covers a larger area, but has slower speeds compared to the faster 5 GHz band that can offer better performance and closer proximity to the router. Security is crucial for Wi-Fi networks, which utilize various encryption methods such as WPA2 and WPA3 to protect user data from unauthorized access, ensuring that connections remain safe while still allowing devices to communicate seamlessly. When devices connect to a Wi-Fi network and send or receive information, the data is divided into packets that travel through the air to their destination, where they are reassembled, allowing for real-time communications such as streaming videos, playing games, or browsing websites. The effectiveness of a Wi-Fi connection can be influenced by several factors, including distance from the router, obstructions like walls or furniture, and interference from other electronic devices, which can affect the quality and speed of the internet experience. The evolution of Wi-Fi technology over the years has seen the introduction of various standards, each improving upon the last in terms of speed, range, and efficiency, leading to the current Wi-Fi 6 802.11x, which significantly enhances connectivity for multiple devices. The benefits of using Wi-Fi in both personal and professional settings include the convenience of mobility, as users can connect their devices without being tethered to a wall, allowing for greater flexibility in how and where they access information. A credit card is a plastic card issued by financial institutions that allows the cardholder to borrow funds, typically at the point of sale, to pay for goods and services which can be repaid over time with interest if not paid in full by the due date. When a purchase is made, the cardholder swipes or inserts their credit card into a card reader, which then communicates with the credit card network to authorize the transaction based on the available credit limit. Once the transaction is authorized, the payment amount is deducted from the cardholder's available credit, which will need to be repaid in accordance with the terms set by the issuing bank, typically summarized in a monthly statement. Credit cards often come with various terms and conditions, including interest rates, annual fees, and rewards programs, which can significantly affect the cost of borrowing if the outstanding balance is not paid off in full each billing cycle. Many credit cards offer rewards programs that allow cardholders to earn points, cashback, or travel miles for each purchase they make, incentivizing responsible usage while also enhancing their overall spending experience. Using a credit card responsibly by making timely payments and keeping the balance low can positively impact the cardholder's credit score, which is crucial for securing loans, mortgages, and other forms of credit in the future. However, failing to manage credit card debt can lead to financial difficulties, as high interest rates can quickly accumulate, resulting in a cycle of debt that becomes increasingly challenging to escape. To avoid these pitfalls, it's essential for consumers to educate themselves about responsible credit card use, including understanding their spending habits, creating a budget, and knowing how to read their statements accurately. Additionally, it is crucial for cardholders to protect their personal and financial information to prevent fraud and identity theft, which can occur if credit card details are compromised or mishandled. By utilizing cybersecurity measures such as strong passwords, secure connections, and monitoring account activity, consumers can significantly reduce the risks associated with using credit cards online and protect their financial well-being. A compass is an essential navigational instrument that utilizes the Earth's magnetic field to determine direction, typically consisting of a magnetized needle that aligns itself with the magnetic poles, providing the user with a reliable means to orient themselves in relation to the cardinal directions of north, south, east, and west. To effectively use a compass, one must first hold it level in their hand to ensure the magnetized needle can freely rotate, allowing it to point accurately towards magnetic north, which is essential for determining one's direction before plotting a course on a map. Once the compass is held level, the user can read the markings on the compass dial, which measure degrees from 0 to 360. This allows them to find their bearing and set a course by aligning the direction of travel arrow on the base of the compass with the desired heading indicated on the dial. For more accurate navigation, especially in unfamiliar terrain, users can employ the technique of triangulation by taking bearings on at least 2 visible landmarks, marking these angles on the map, and drawing lines from the landmarks to determine their precise location. Additionally, it's important for navigators to account for magnetic declination, which is the angle difference between true north and magnetic north, as this discrepancy can vary by location and affects the accuracy of the compass readings, necessitating adjustments to ensure proper navigation. Understanding the evolution of the compass is also fascinating, as it has been used for centuries in maritime navigation, dating back to the Han Dynasty in China, where it was originally employed not just for direction, but also for geographical orientation, thereby shaping the course of exploration and trade throughout history. In contemporary times, the compass has evolved significantly with advancements in technology, leading to the development of digital compasses that integrate GPS functionality and offer additional navigation features, providing users with real-time information about their location and movement even in challenging environments. Photosynthesis is a vital biochemical process that occurs in green plants, algae, and certain bacteria, where chlorophyll-containing cells absorb sunlight, which then triggers a series of chemical reactions that ultimately transform carbon dioxide and water into glucose and oxygen, serving as the primary source of energy for the vast majority of life on Earth. The process begins with the absorption of sunlight by chlorophyll, the green pigment found in plant cells, which captures light energy and uses it to split water molecules into hydrogen and oxygen, where oxygen is released into the atmosphere as a byproduct. Following the light reactions, the generated energy fuels the Calvin cycle, a series of chemical reactions occurring in the stroma of chloroplasts, where carbon dioxide from the atmosphere is fixed into organic molecules and ultimately converted into glucose, providing energy that supports plant growth and sustains various ecosystems. In addition to producing glucose, photosynthesis also plays a critical role in regulating atmospheric gases, as plants take in carbon dioxide through tiny openings called stomata and release oxygen, thus contributing to the balance of gases in our environment and supporting life on Earth. However, human activities such as deforestation and pollution threaten this delicate balance, as the reduction of plant life decreases the rate of photosynthesis, leading to higher levels of carbon dioxide in the atmosphere and exacerbating climate change, which in turn impacts all living organisms. To combat these environmental challenges, scientists are exploring innovative solutions such as artificial photosynthesis, where technology is developed to mimic the natural process of plants in order to create clean energy and reduce greenhouse gas emissions, thus contributing to a sustainable future. Education plays a crucial role in raising awareness about photosynthesis and its significance in our ecosystems. As young learners participate in interactive activities that foster a deeper understanding of how plants contribute to life on Earth and the importance of protecting our natural resources. An elevator is a mechanical device that serves as a means of vertical transportation, designed to move people or goods between different levels of a building, and it operates through a system typically involving cables and pulleys, where the elevator cab is attached to a set of strong cables that run over a sheave, allowing it to ascend or descend smoothly within a shaft. The system is powered by an electric motor that drives the sheave, which in turn moves the cables, while the entire operation is closely monitored by a control system to ensure safe and efficient travel, incorporating various safety mechanisms such as emergency brakes and limit switches to prevent accidents and ensure passenger safety. Additionally, the elevator operates using a series of sensors and indicators that notify users of its position and help regulate its speed, making it not only a convenient mode of transportation but also an essential element of modern architecture, allowing for greater accessibility in high-rise buildings and multi-floor complexes. Furthermore, the design of elevators has evolved over the years, incorporating advanced technologies such as regenerative drives that recycle energy to enhance efficiency while reducing operational costs, demonstrating how innovation in elevator engineering contributes to sustainable building practices and improves user experience. Moreover, the continual development of smart elevators equipped with artificial intelligence and IoT capabilities allows for adaptive learning based on user patterns, which optimizes travel routes and decreases wait times, showcasing the transformative impact of technology in elevating urban mobility and enhancing overall building functionality. In addition, elevators now feature advanced safety systems such as real-time monitoring and emergency communication tools, which provide immediate assistance in case of power outages or malfunctions, thus ensuring that passenger safety remains a top priority while maintaining the convenience that elevators offer in our daily lives. A sewerage system, which is a crucial infrastructure component, consists of a network of pipes, treatment facilities, and processes designed to collect, transport, and treat wastewater from homes and industries, ensuring that it is cleaned before being released back into the environment. Once the wastewater reaches the treatment plant, it undergoes several steps, including screening to remove large debris, sedimentation to separate solids from liquids, and biological treatment where microorganisms degrade organic pollutants, ultimately resulting in cleaner water. After undergoing various treatment methods, the treated wastewater is tested for quality to ensure it meets environmental standards before it is safely discharged back into natural bodies of water, ultimately contributing to a cleaner ecosystem. To maintain an effective sewerage system, continuous monitoring and community involvement are essential, as public education regarding proper waste disposal and infrastructure upgrades help ensure that the system operates smoothly and efficiently over time. Regular maintenance and upgrades to the sewerage system not only enhance its efficiency but also play a vital role in preventing public health hazards and environmental contamination, thereby providing significant long-term benefits to communities. Investing in education and outreach programs helps to foster an understanding of the sewerage system's importance among younger generations, ensuring that they appreciate the value of clean water and the impact of effective wastewater management on their communities. The integration of sustainable practices within sewerage systems is increasingly critical as urban areas strive to balance development with environmental protection, which includes considering how wastewater management affects local ecosystems and wildlife. Innovative approaches, such as integrating green infrastructure into sewerage systems, not only enhance the efficiency of stormwater management but also provide recreational spaces for communities, demonstrating a commitment to both infrastructure improvement and public well-being. A heart pacemaker is a small medical device that sends electrical impulses to the heart to help it beat at a normal rate, and it works by monitoring the heart's rhythm and providing stimulation when necessary, ensuring that the heart maintains an adequate blood flow to the body. The device is typically implanted under the skin in the chest area, where it connects to the heart with thin wires, ensuring that if the heart beats too slowly or skips a beat, the pacemaker can detect this and deliver electrical impulses to normalize the rhythm. When the heart's natural pacemaker, known as the sinoatrial node, fails to function correctly, this artificial device takes over the role by ensuring that the heart receives timely signals to contract, thus maintaining a consistent heartbeat. After the implantation procedure, patients are monitored closely for a short period, and once cleared, they can typically return to their normal activities while following specific guidelines to ensure the pacemaker functions effectively over time. Regular follow-up appointments are essential for ensuring that the pacemaker is functioning properly, during which healthcare professionals may adjust the device's settings based on the patient's individual heart rhythms and overall health. With proper care and regular monitoring, many individuals with a pacemaker can lead full, active lives, enjoying their favorite activities while being mindful of certain precautions, such as avoiding strong magnetic fields and engaging in high-contact sports. Education and support are crucial for those living with a pacemaker, as sharing experiences and accessing resources can help patients manage their condition effectively while understanding the importance of heart health in their daily lives. Advancements in pacemaker technology have led to devices that are smaller, more efficient, and equipped with features that allow them to adapt to the patient's needs, thereby enhancing the overall effectiveness of heart rhythm management. A mirror is a smooth surface that reflects light, allowing us to see our own image as it bounces back, and this reflection occurs due to the principle of light behavior, where incoming light rays strike the reflective surface at an angle and are reflected at the same angle, creating the visual representation we recognize as our reflection. Additionally, mirrors can be categorized into flat, concave, and convex types, each serving different purposes. Flat mirrors reflect images without distortion. Concave mirrors can magnify images by focusing light to a single point, which is why they are often used in makeup application, while convex mirrors offer a wider view, making them ideal for security applications, such as monitoring traffic at intersections. Furthermore, the construction of a mirror typically involves a reflective coating, often made from silver or aluminum, applied to a glass surface, which serves to enhance the reflection quality by minimizing light absorption. And with technological advancements, mirrors have evolved to include smart features such as touch screens and built-in lighting that can interact with users, blurring the lines between simple reflections and high-tech interfaces. Historically, mirrors have transformed through various cultures, with ancient civilizations creating reflective surfaces from polished metals such as copper and bronze, while the technology progressed to glass mirrors around the 12th century, leading to significant improvements in beauty and function, as reflected in the design and craftsmanship seen in antique mirrors that often represented status and wealth, highlighting the evolution of mirrors not just as tools for reflection but also as decorative art pieces. In educational contexts, the study of mirrors is crucial for understanding fundamental physics concepts such as the law of reflection, which states that the angle of incidence equals the angle of reflection, making mirrors essential tools in classrooms to illustrate optical principles. While in contemporary interiors, mirrors are not only functional but also serve as design elements that add depth and style to spaces, proving their versatility beyond mere reflections. Cheese is a dairy product derived from milk through a process of coagulation that involves curdling the milk with the help of bacteria and enzymes, during which the solid parts separate from the liquid whey, resulting in the formation of curds, which are then drained, pressed, and aged to develop various flavors and textures. The first step in making cheese begins with warming the milk to a specific temperature before adding cultures that help ferment the lactose into lactic acid, followed by the addition of rennet, which causes the milk to coagulate, forming curds that are then cut into smaller pieces to facilitate whey drainage. After curds have formed and whey has been drained, the curds are then cooked and stirred at controlled temperatures, allowing them to expel even more whey, after which they are placed into molds where they are pressed under controlled conditions to create the desired shape and texture. Once the cheese has been molded and pressed, it enters the aging phase. where it is stored in a controlled environment that maintains specific temperature and humidity levels, allowing enzymes and bacteria to continue developing flavors, while the cheese is monitored regularly to ensure even aging and prevent spoilage. Finally, after the aging process is complete, the cheese is ready to be packaged and enjoyed, whether served on its own, incorporated into recipes, or paired with wines and accompaniments, showcasing its unique flavors and textures that have developed throughout the meticulous production journey. Understanding the journey of cheese from milk to the final product not only enhances appreciation for this culinary delight, but also sparks interest in exploring different types of cheese around the world, leading to vibrant markets and workshops that celebrate the art of cheesemaking and its rich cultural significance. The foundation of great cheese begins with high-quality milk sourced from healthy animals, often raised sustainably on farms that prioritize animal welfare, as this directly influences the flavor profile and texture of the cheese, making it essential for cheesemakers to build strong relationships with their dairy suppliers. A light bulb is an electrical device that produces light when electricity passes through its filament, which then heats up and emits illumination, a phenomenon that has evolved from incandescent bulbs to more energy-efficient options like LED and CFL, showcasing the progression of technology in lighting solutions. The process begins when electricity flows into the light bulb's base, where it connects to the internal components, allowing current to travel through the filament in incandescent bulbs or through semiconductor material in LED bulbs, resulting in different methods of light generation depending on the type of bulb used. In incandescent bulbs, the electric current heats the tungsten filament until it glows, while in LED bulbs, electrons move through a semiconductor material, releasing energy in the form of photons to produce light more efficiently, which has a significant impact on energy consumption and environmental sustainability. The choice of a light bulb can greatly influence not only the brightness and color temperature of a space, but also the overall energy efficiency of the lighting system, leading to advancements in smart lighting technology that allow users to control their light sources from remote devices or automate them based on personal preferences. As technology continues to evolve, smart bulbs incorporate features like dimming capabilities, color-changing options, and connectivity to home automation systems, making it easier for consumers to create the perfect atmosphere while maximizing energy savings and reducing their carbon footprint. Ultimately, the transition from traditional incandescent bulbs to modern energy-efficient options not only saves consumers money on their electricity bills, but also plays a crucial role in reducing overall energy consumption globally, contributing to a more sustainable future for both lighting technology and the environment. Moreover, as society becomes increasingly aware of environmental issues, the proper disposal and recycling of light bulbs, especially those containing hazardous materials like mercury in CFLs, are essential practices that consumers must adopt to help mitigate pollution and promote responsible waste management. A microwave is a kitchen appliance that cooks or heats food by using electromagnetic radiation in the microwave frequency range, which effectively causes water molecules in the food to vibrate and produce heat through a process known as dielectric heating. The heart of the microwave is the magnetron, a device that generates microwaves by converting electrical energy into microwave radiation, which then travels through a waveguide and enters the cooking chamber where it evenly penetrates the food. When the microwaves are emitted inside the cooking chamber, they reflect off the metallic interior and penetrate the food, effectively causing the water molecules to vibrate rapidly, which generates heat and thus cooks the food from the inside out. Microwave ovens are designed with user-friendly interfaces that allow individuals to easily set cooking times and power levels, making meal preparation more efficient and convenient in today's fast-paced lifestyle. The convenience of microwave ovens lies in their ability to significantly reduce cooking time, allowing families and individuals to prepare meals swiftly, which is especially beneficial for busy lifestyles and shared spaces like offices. While microwave ovens are incredibly efficient and convenient, it is crucial to follow safety guidelines, such as avoiding metal utensils and using microwave-safe containers to prevent accidents and ensure the longevity of the appliance. In addition to their speed and convenience, microwaves are often more energy efficient than conventional ovens, consuming less electricity over time, which makes them an environmentally friendly choice for cooking. From reheating leftovers to cooking a wide variety of meals such as popcorn, vegetables, and even baked goods, microwaves have proven their versatility as an indispensable kitchen appliance that caters to diverse culinary needs. As technology advances, modern microwaves are equipped with smart features that allow users to connect to their home network, enabling remote control and access to a variety of recipe apps that enhance cooking experiences. A desalination plant is a facility specifically designed to convert seawater into fresh drinking water through various processes, primarily reverse osmosis or distillation, which effectively removes salt and impurities from the water, making it suitable for human consumption. The first step in the desalination process involves drawing in seawater through intake pipes, which is then pre-treated to remove larger particles and contaminants, ensuring the efficiency of the subsequent filtration processes. Next, the seawater is pushed through high-pressure pumps into reverse osmosis membranes, where only freshwater molecules can pass through, leaving the concentrated salt water behind, resulting in the extraction of potable water from the saline source. Following the filtration process, the desalinated water is collected in storage tanks where it undergoes rigorous testing to ensure it meets safety and health standards before being distributed for public consumption. Finally, many modern desalination plants incorporate renewable energy sources such as solar or wind power to reduce their carbon footprint, ensuring that the fresh water produced can be effectively distributed to communities in need, thereby enhancing water security. In summary, the desalination process not only highlights a technological marvel that transforms saline water into a vital resource, but also underscores the importance of sustainable practices and innovative technology in addressing global water scarcity issues. As water scarcity becomes an increasingly pressing issue around the world, desalination plants play a crucial role in supplying fresh water to arid regions, thereby supporting both local economies and ecosystems that rely on a stable water supply. Furthermore, ongoing research and collaboration among experts aim to enhance desalination technologies, making them more efficient and affordable, while educational initiatives help raise awareness about the significance of sustainable water management and the role of desalination in future water supplies. A nuclear power plant is a facility that harnesses the energy released from nuclear fission reactions to generate electricity, and it operates by using uranium fuel rods that undergo a controlled chain reaction within a reactor, producing heat that transforms water into steam, which then drives turbines connected to generators to produce electrical energy. The heat generated from the nuclear fission process is absorbed by water circulating around the reactor core, where it then turns into steam, and this steam travels through pipes to turn turbines that generate electricity, while the remaining water is cooled and returned to the reactor. Once the steam passes through the turbines and spins them to create electricity, it then enters a condenser, where it is cooled back into water using a secondary cooling loop or nearby water source, completing the cycle efficiently while maintaining strict safety protocols to prevent any leaks or accidents. After the nuclear fuel has been used and is no longer efficient for energy production, it becomes radioactive waste that requires careful handling and long-term storage solutions, often placed in specially designed containers that can securely hold the material until it loses its radioactivity over time, while ongoing research seeks to find more effective ways to manage and dispose of this waste. Nuclear power plants are equipped with multiple safety systems that provide protection against accidents, including redundant cooling systems, containment structures designed to withstand natural disasters, and comprehensive training for staff to ensure they can react effectively in emergencies, demonstrating the industry's commitment to maintaining safety standards. In addition to providing a significant source of reliable electricity, nuclear power plants play a critical role in reducing carbon emissions compared to fossil fuels, contributing to the fight against climate change while also facing public scrutiny regarding safety and waste management, leading to ongoing dialogues between plant operators and local communities. A wind turbine is a device that converts kinetic energy from the wind into mechanical energy, which is then transformed into electricity through a generator. This process begins with the wind blowing against the turbine blades, causing them to rotate, which in turn spins a shaft connected to the generator, thus generating power for homes and businesses. As the blades rotate, they drive a gearbox that increases the rotation speed for the generator, optimizing the conversion process. The electricity produced is then transmitted through power lines to the grid, providing renewable energy while reducing reliance on fossil fuels. Wind turbines can be installed onshore or offshore, with each location presenting unique advantages. Onshore turbines benefit from lower installation costs and ease of access for maintenance, while offshore turbines capitalize on stronger and more consistent winds, resulting in higher energy generation potential. Proper maintenance is crucial for wind turbines to ensure their efficiency and longevity. Routine inspections and repairs are performed on the blades, gearbox, and electrical systems to prevent malfunctions and maximize energy output over time. Despite being designed to withstand harsh weather conditions, including high winds and storms, wind turbines are equipped with safety mechanisms that automatically turn the blades out of the wind to prevent damage. Ongoing research continues to improve turbine technology, enhancing efficiency and reducing costs. Public awareness and acceptance of wind energy are growing, fueled by educational initiatives demonstrating its benefits as a clean, sustainable alternative to fossil fuels. These efforts emphasize wind power's role in combating climate change while providing job opportunities and promoting energy independence. As technology advances, innovations such as smart grid systems and enhanced turbine designs are being developed to make wind energy even more efficient and reliable, ultimately contributing to a more sustainable future by integrating renewable sources seamlessly into existing energy infrastructures. Bluetooth is a wireless technology standard that allows for the exchange of data between devices over short distances, typically within a range of about 10 meters. Using radio waves in the 2.4 GHz frequency band, making it ideal for connecting peripherals like headphones and keyboards without the need for physical cables. The technology operates through a master-slave architecture, where one device, known as the master, controls the connection and the other devices, or slaves, respond to the master's commands, enabling efficient data sharing among multiple devices while maintaining low power consumption. To establish a connection, devices must go through a pairing process, which often involves entering a PIN or confirming a code displayed on both devices, ensuring that only authorized devices can connect to each other securely. Bluetooth technology supports various profiles that define specific use cases, such as A2DP for high-quality audio streaming, HFP for hands-free communication, and FTP for file transfers, allowing devices to cater to different needs seamlessly. As Bluetooth technology has evolved, it has significantly improved in terms of range and data transfer speed, with newer versions like Bluetooth 5.0 offering up to 4 times the range and twice the speed of previous iterations, making it more versatile for various applications. The integration of Bluetooth into smart home technology has allowed users to create interconnected ecosystems where devices can communicate and be controlled from a single platform, enhancing convenience and energy efficiency in daily life. The widespread adoption of Bluetooth technology has led to the emergence of a vast array of consumer products, from wireless earbuds to smart appliances, each designed to take advantage of this convenient connectivity for a more enjoyable and integrated user experience. An X-ray machine is a pivotal tool in modern medicine that utilizes controlled radiation to create images of the inside of the body, enabling healthcare professionals to diagnose and monitor various medical conditions. When an X-ray is performed, the machine emits a beam of radiation that passes through the body and is absorbed by different tissues at varying levels, allowing for a contrast in the resulting images. The images produced by the X-ray machine are captured on film or digital sensors, and they reveal important details such as bone fractures, tumors, and the condition of internal organs, aiding in accurate diagnosis. Before the X-ray procedure begins, patients are often required to remove any clothing or jewelry that may obstruct the imaging process, ensuring clear and precise images are obtained without interference. After the imaging is complete, a trained radiologist interprets the X-ray results by examining the images for any abnormalities and then communicates these findings to the referring physician for further action. Following the procedure, patients may receive specific instructions regarding any follow-up care or additional tests necessary based on the results, ensuring they understand the importance of the X-ray findings in their overall health. Emphasizing patient safety, various protocols are implemented during X-ray procedures, including the use of lead aprons to protect sensitive areas and minimizing radiation exposure, reinforcing the commitment to patient health. To ensure optimal performance and safety, regular maintenance and calibration of the X-ray machine are crucial, as this guarantees that it operates within established safety standards while providing accurate imaging. Continual education on the latest advances in X-ray technology is vital for healthcare professionals, as it enhances their ability to utilize these machines effectively and keep up with evolving diagnostic techniques. Mobile X-ray units are increasingly being deployed in community health settings to provide accessible imaging services, ensuring that even underserved populations receive the necessary diagnostic care without barriers.